2.5 is called bin packing. Specifically, we're going to be doing one-dimensional. But overall, the chapter is on optimization. And when we talk about optimizing something, we're trying to find the minimum or the maximum. We're trying to minimize things, or we're trying to maximize. And this kind of stuff comes up all the time in real life. You might be trying to minimize wasted space, like these guys packing these boxes. You want to pack those cans in there so that you minimize wasted space. You might want to maximize your time usage. You might, if you're buying things for a project, which is what we're going to talk about a lot, this guy down here cutting wood, he's building a house. He's going to want to minimize his extra materials. Therefore, minimizing his cost. We want to maximize our efficiency. But we do things like this all the time, all right? And so this guy right here cutting boards, this is going to be a similar concept to what we talk about in this lesson, bin packing. There is 3-dimensional and 2-dimensional, but we're just going to be talking about 1-dimensional for this lesson. 1-dimensional algorithms, also called a stock cutting or board cutting. There are 4 different algorithms: next fit, first fit, best fit, worst fit. And I always thought that sounded like a Dr. Seuss book or something, but there's 4 different types of board cutting algorithms. And so we need to learn all 4 of them. The next fit algorithm, you're going to put the next weight or board in the current bin. First fit, put the next weight in the first bin in which it fits. Best fit, put the next weight in the bin with the least space. Worst fit, put the next weight in the bin with the most space. Now, these terms don't really seem to make sense. And when you start in these algorithms, you're going to be wondering why in the world we would do it this way. But when we talk about algorithms, an algorithm is a set of steps. And if you are programming a computer or programming a machine, you have to give that machine a specific set of steps and tell it exactly what to do. And so these are just 4 different ways that you could tell that computer exactly what to do in what order. So next fit is current bin, first fit, first bin, best fit, least space, worst fit, most space. Example 1, a builder needs the following length and feet of boards to complete a project. Determine the minimum number of 8-foot boards needed to complete the project. Then briefly discuss efficiency and wasted material. So I think why we would want to do this is obvious. He's trying to minimize the number of boards he has to buy so he can minimize his costs. But we're going to do this one, part A, using the next fit algorithm. Remember next fit, remember the word current. And it says next fit decreasing, and that's just because all of those numbers that you see are written in decreasing order. So if I didn't put decreasing, they could be in any order you want, but decreasing, we're just going to do them all decreasing just to make it as simple as possible. So we have 8-foot boards is what this says. And so essentially what we're doing is we're going to buy some 8-foot boards in order to make these cuts. We've got a 6-foot cut and another 6-foot cut, and so on and so on and so on. You got 4 6s, 3 5s, 4 4s, 4 3s, 2 2s, and 4 1s. We've got all those cuts to make out of 8-foot boards, and we want to know what's the least number of 8-foot boards to buy. So this picture I've got here is like a kind of a blank model of a bunch of 8-foot boards, and you see 14 of them, but they're really, you should pretend like they're invisible and they're not there. The dotted lines, they're invisible lines. You really don't see them. So we don't know how many boards there are at this point. I assume it's going to be less than 14 boards, but we don't know at this point until we start filling them in. Okay, so you look at the first cut, and this says we need a 6-foot cut. And so what I would do, count up 6. This is going to represent a 6-foot board cut out of an 8-foot board. You should notice 1, 2, 3, 4, 5, 6, 7, 8. That's supposed to show you 8 feet is what that's supposed to show you. But that first cut is 6 feet. Now, next fit means current bin. So what we have to do, and this is not going to make sense to you at first, but what we have to do is when we make this next cut, the next 6-foot cut, we want to try to fit it in that same current bin that we're in. But since that's not going to fit, what we have to do is close the bin off. Close the bin. And we don't even get to use that space. And you're thinking, well, why wouldn't I save that for later when I've got that 2-footer over there? That would make perfect sense to a human being, but you can't, machines can't really think about that just yet. They only follow directions. So according to this algorithm, we're going to look at the current bin only. And if it won't fit, we move to the next bin or the next board. We're going to put that second 6-footer. Okay, we did the first one and the second one. And then we've got a third 6-footer where it won't fit in the current bin. So we open up a new bin and we put that 6-footer, we make that 6-foot cut. There's another 6-footer, won't fit. So I have to open up a new bin or cut a new board, buy a new board. This seems really inefficient. I know it, but just bear with me. We'll get to more efficient methods here in a bit. The next one's a 5. Well, it won't fit in the current bin, so I need a new board. And then I've got another 5. Won't fit, need a new board. The third 5 won't fit, so I need a new bin. I'm on my 7th board right now. Next cut is a 4-footer. Oops, that's not going to fit. So I need a new board or bin. I've got that second 4-footer, and sweet, that one's actually going to work. Okay, that's cool. That's the first board that I've used up completely. Next one, 4. Got a new bin, and then that fourth 4 is also going to fit. So both of those will fit. Next cut is a 3-footer. Get a new board. Next cut is a 3-footer. And so your question is, will it fit? Yeah, it'll fit. So I can use that. Now you've got another 3. Another 3-footer won't fit inside the current bin. So you've got to open up a new bin or board. The last 3, it's going to fit inside the current one. The next one is a 2. And again, your question is, will it fit? Yeah, it's going to fit in the current bin, so we put it right there. 2, need a new board. Now we've got a 1, it'll fit. Second one, it'll fit. Third one, it'll fit. Fourth one, it'll fit. And now we're done, so we can waste that or close that. So the main part of the question, I think, is how many boards do we need? And it looks like we need 12 boards. So we're going to say need 12 boards. And it doesn't take a whole lot of thought to realize this is very inefficient because you're wasting a lot of pieces of wood that you could have maybe used. And so this is not how I would do it. It's probably not how you would do it, but this is the next fit algorithm and what it's saying. So let's talk about waste for a second. All of those X's are waste. And I'm going to list the waste in a very specific way, and I want you to copy this. I want you to tell me the length of the cut and then how many there are. So this first one, the blue one, is a 2-foot cut. you've got a 2-foot cut, and then count how many there are. Count the quantity. I see 1, 2, 3, 4, 5, 6 2-foot waists. So 2 feet times 6, that's 12 feet overall of waist, right? And then you've also got a 3-footer. You've got a 3-footer, and it looks like there are 3 of them, equals 9 feet of waist. So you've got a total 21 feet of waist. So you've got 6 2-footers, 3 3-footers. That's a total of 21 waisted feet. Well, what about the total? If you think about the total, these are 8-foot boards, and we're buying 12 of them. This carpenter or whatever, a builder, needs to buy 12 of them. 8 times 12 is 96 total feet. So the total feet of the boards, 96, we're wasting 21 of those 96 feet. So I want to talk about how much I use. If you subtract off that 21, that's 75. We're using 75 feet of that. And so we can talk about efficiency. If you think about 75 feet used up out of 96, 75 out of 96, 78.125. Let's call that 78.1. That's about 78.1% efficient. It's not very good. We needed 12 boards, and we've got 78.1% efficiency there. Not real strong, a lot of wasted space, a lot of wasted boards. So part B, we're going to do the exact same problem, but this time we're going to use a different algorithm. We're going to use the first fit. Okay, so this one's quite a bit different. You're going to use the first bin that it fits in. All right, so you're not going to close them off quite as quickly. So we start with a 6. That's our first cut. And then the 6-footer won't fit, so we open up a new bin. But we don't throw the old one out yet. We're going to save that. We might end up using that later, and you know we probably will. So we've got that one and that one. The third 6 won't fit in any of the bins, so we open up a new one. Fourth one, same thing. Open up a new one. This 5 won't fit in any of them, so we open up a new one. Buy a new board. And that second 5, same thing. It won't fit, so we open up a new one. But the main difference so far, I know it seems the same, but the main difference is we haven't thrown anything away yet. Third 5. Okay, here comes a 4. Won't fit in any of those bins, so we open up a new one. 4, it'll fit inside this one. Next 4 won't fit, so we open up a new one. Last 4, it'll fit inside this one. So far, everything's been the same, except I haven't X'd anything out yet. All right, now here's the first place where it's different. Okay, this 3, what you do is you look and you find the first one that it'll fit in. The first one that it'll fit in. And so that 3 is going to fit right here. So I'm actually going to use that piece right there. And then the next 3, same thing. It'll fit right there. That's the first one it fits in. And then the next 3, the first one it fits in would be right there. First one it fits in. Now that last 3, it's not going to fit anywhere, so we need to open up a new board. Now again, here's where it's going to be different. Because that 2, you go to the first one it fits in. First one it fits in would be way over here. And then another 2, first one it fits in right there. And then that 1, first one it fits in is going to be right here. And then the next one, the first one it fits in is right there. And then another one, first one it fits in is right there. And then the last one, first one it fits in is right there. And so only thing we didn't use was right here, X that out. That's a lot more efficient if you look at it. And you know, the main part of the question is how many boards do I need? How many boards do I need? Well, it looks like we need 10 boards for this one. Need 10 boards or bins, depending on the context of the problem. So let's look at your waste. All right, as for the waste, again, I want you to talk about it as it's a 5-foot board and a quantity of 1. Put it in that order, not backwards. It'll be important later. So that's 5 total feet of waste. So talk about the efficiency then. What's the total amount of feet that we had? Well, we've got 8-foot boards, and we've got a quantity of 10 of them, so that's 80 total feet. Subtract off the waste, that's 75 feet that we used. So 75 out of 80 gives us our efficiency number, 93.8. That's about 93.8% efficient. So that's much better. I wish we could do better than that, but I'm not sure that we can. That's really not bad. The only piece, you've only got one extra piece left over. It's a 5-footer. Maybe we save that. We can use that for our next project. Part C. We're going to do the same exact problem. 8-foot boards, those cuts, but this time best fit. Best fit means least amount of space. Right, I know that seems like a contradiction. Best fit, least space, but that's what we're going to do. So start with the 6. Next 6. It's not going to fit. So next 6. Fourth 6. Five's not going to fit. Same thing. Same thing. Four is not going to fit, so open up a new one. Okay, so we're here. Now that second 4, you're trying to fit it where there's the least amount of space, but obviously that's not going to fit. Okay, so I shouldn't have X'd that out, but that's just where we're looking. It's only going to fit right here. And so I know you didn't have to think too hard about that, but that's where it fits, but we're trying to fit it in the least amount of space. 4 is not going to fit anywhere, so we go here. The last 4 is going to go here. All that's pretty obvious, I think. All right, so then that next 3. We're trying to put the 3 where it has the least amount of space. And, well, it won't fit in any of the 2s, so it's going to fit somewhere here. Okay, that's the least amount of space. And the next 3 is going to fit here because that's the least amount of space in which it'll fit, of course. And then the next 3 fits here in the least amount of space. And this, you know, this seems like the exact same as the last thing. Everything's the same so far. It won't always be. This next 3 won't fit anywhere, so we go here. And the next 2, put it in the least amount of space that it'll fit in. That's this one. Least amount of space is this one. 1 least amount of space is here. 1 least amount of space is here. 1 least amount of space is here. Last one, least amount of space is here. Got them all. X that out. It turns out that that's the exact same solution as the last one. That's exactly the same thing as we got. It won't always be the same. We need 10 boards again. And just like the last one, we've got a 5-foot times quantity 1 equals 5 feet of waste. We used up 75 out of 80 total feet, which was 93.8%. efficient. Best fit was the same as first fit. Now we're going to do worst fit. It's going to be different though. Worst fit means most space. So it starts off very similar. 6-footer, cut a new board. 6-footer, cut a new board. 6-footer, 6-footer. 5-footer won't fit. Open a new bin. Open a new bin. Open a new bin. Okay. Most amount of space. 4-footer won't fit. Open a new bin. 4-footer, most amount of space is going to be right here. 4-footer, new bin. 4-footer, most amount of space is going to be right here. So far, it seems to be exactly the same, right? 3-footer, most amount of space is this one. Most amount of space. And again, I mean, I might not have mentioned this, but if it's a tie, I'm going to the left side. The next one, most amount of space is right here. The next one won't fit, so I have to open a new bin right there. Okay. So far, this is exactly the same as the previous two, but here's where it's going to get different. For this too, this may not be what you want to do, but this worst fit algorithm says put it in the most amount of space. That's this one right here. That has the most amount of space. And then this next two, the most amount of space is right here. And then we move to the ones. The most amount of space is going to be this one right here. And then I know this doesn't seem to make sense to you, but the most amount of space is this one. The most amount of space is this one. And the most amount of space is this one. And once we're done, we can cross off the waste right there. That's a very similar solution because we still need 10 boards. This is slightly different though. When we talk about the waste this time, they're all 1-foot boards. It's a 1-foot board with a quantity of 5. So yeah, that's still 5 feet of waste. And we're still using 75 out of 80 feet for the same number, which was 93.8. We're still 93.8% efficient. But I don't know about you. I'd maybe rather have one 5-foot board like this algorithm than 5 1-foot boards. So I guess that's a little bit different, but very, very similar solution. I need 10 boards.
Example 2a, use a bin packing calculator to find the most efficient solution to the problem using 10-pound bins. So you can see all the cuts, and it's about the same, maybe exactly the same, but the main difference is instead of 8-foot boards, we're using 10-foot boards or bins or whatever you want to say. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10-foot bins, 10-pound bins, 10-foot boards, whatever. So if you go into Goldadder's math sites and search for the bin packing calculator, we can do stock cutting problems. We can do bin packing problems. And it works pretty nice, but you got to know how to use it. So a lot of this is already here by default, but the container size for this problem is 10. That's what all of our boards are going to be before we cut them. So now here, you're going to have to enter in your numbers. And so I tried to stress earlier that I want the length and the quantity, and that's how this is going to be. It's going to be length first, quantity second. If you enter it in backwards, you're going to get a really confusing result. So write that down if you need to, but this is going to be length, this is going to be quantity. So let's look at our cuts. It looks like we've got 6-foot cuts and 3 of them. So 6 foot cuts, I'm going to have 3 of them. And 5 foot cuts, I've got 3 of them. Four-foot cuts, I've got 4 of them. Quantity 4. 3-foot cuts with quantity 4. 2-foot cuts or 2-pound cuts with quantity 2. Already got it. 1-foot cuts with quantity of 4. All right, double check your numbers. We're using 10-pound bins. We want all those cuts and quantities, and we're going to calculate. So it takes you through, and it may not put them in the same order that as what we did them in before, but next fit decreasing, and you can kind of see the breakdown. And this is how you'd actually draw the picture. But they're going to end up needing 9 boards, 9 containers, and 76.67% efficiency. General use of containers, that's the efficiency number. So let's see, next fit was 9 and 76. So let's write that down. Next fit was 9 and 76.67. All right. What else do we have? First fit. All right. Notice over here on the right side, we've got a bunch of 100%. That's saying we're using up the entire board. Over here, we've got all these 60s and 40s, meaning we're wasting some stuff. So this looks a lot less wasteful. We're using 7 containers or 7 boards, and it's 98.57%. That was first fit. We used 7, and it was 90, what was it? 8.57. And so worst fit, notice it's out of order. It's not the same order as what we did it in. Same thing, right? Best fit, same thing. 7 boards, 98.57. 7 boards, 98.57. So worst and best, same thing. So which method or methods produce the most efficient solution? Well, it looks like first fit, worst fit, and best fit. The minimum number of boards needed are 7. And the waste, okay, we see that it's a 98.57% efficient. But that doesn't really tell me about the waste. Let's go back and look. Let's look at look at how they drew out the boards. Notice there's a 6 and a 4, a 6 and a 4, a 6 and a 4. Let's just go ahead and draw that out. We had a 6 and a 4, and we had that 3 times. And then we had a 5, 5, and a 5, 4, 1. Oh, 3 times. Oops. Five, 4, 1. 3, 3, 3, 1. 3, 2, 2, 1, 1. So it looks like the only waste piece we have is this little thing right there. Looks like our waste, we've got a 1 footer with a quantity of 1 is 1 foot. 1 foot wasted. And so these are 10-foot cuts. You got 10 foot times 7 boards is 70 feet. And so it looks like we're wasting 1 foot. So 69 over 70, that's probably where our efficiency number came from. Yeah, there we go, 98.57. There's our efficiency number right there. Okay, so problem 2b, it's the exact same thing. It just says least efficient this time. So least efficient was this one, next fit right here, right? Next fit was the least efficient solution in this process. And number of boards needed there was 9. And that efficiency number was 76.67. And we can go back through there and find the boards. We see there are 9 boards. The first 3 boards are just using up 6s. And wasting this bit right here. And then the next 5-5 and 5-4. And wasting this bit. 4-4, 4-3-3. Three, 3, 2, 2. And 1, 1, 1, 1. So we talk about waste. You're wasting 6 feet right here. 6 feet, quantity 1. And you're wasting 4 footers, quantity 3. And you're wasting a 2 footer, just one of those. And you're wasting a 1 footer, one of those. So when we're looking at waste, we've got 6 feet, 12 feet, 2 feet, and 1 feet. Add that up, that's 18, 20, 21. That's 21 feet. 21 feet of waste. And so you got 9 boards. 10 feet times 9 is 90. And you're wasting 21 feet, and that's 69. So again, if you take 69 divided by 90, that's going to be your efficiency number. So 69 divided by 90. 76.67. There's your efficiency. Now, obviously, you could go back and do these problems if you wanted to, but the thing you'd have to change is this time in this problem, you were doing an 8-foot bin or an 8-pound bin. All right, so you'd have to change that number. And I don't remember if these numbers are all the same. You'd have to make sure those are all the same. Yeah, see, this one has 4 6s, but our problem we just did only had 3 6s, I believe. Right, so you'd have to change some numbers slightly. But that's how it's going to work.